Hello everyone. Today, I would like to introduce the next evolution of our electromagnetic brain theory. In version 3, we proposed that cognition could be interpreted as a closed electromagnetic perception action loop, inspired by the functional organization of the human brain. In version 4, we take a significant step forward. We integrate modern radar engineering, electromagnetic sensing, predictive cognition, multisensory intelligence, working memory, geometric cognition, and adaptive decision-making into one unified electromagnetic cognitive architecture. Our objective is not to claim that the biological brain literally implements radar algorithms. Instead, our objective is to develop a unified engineering language capable of describing how electromagnetic interactions can evolve into perception, understanding, prediction, and intelligent action. Everything begins before cognition. Before perception. Before recognition. Before memory. There is physics. Every intelligent system must first interact with its environment through electromagnetic waves. In biological vision, this interaction begins inside the retina. In radar, it begins with transmitted and received electromagnetic fields. We therefore reinterpret the retina as an intelligent adaptive electromagnetic front end. Instead of behaving like a passive sensor, it performs adaptive electromagnetic acquisition. Like a hybrid massive MIMO radar, it performs spatial sampling, adaptive filtering, clutter suppression, matched filtering and compressive sensing before the cortex even receives the information. Intelligence therefore begins at the sensing interface itself. The occipital cortex performs the first electromagnetic reconstruction of reality. Raw electromagnetic measurements become calibrated scattering parameters. S parameters are transformed into impulse responses. Impulse responses become range profiles. Multiple antennas reconstruct range angle space. Confocal imaging concentrates coherent electromagnetic energy. Tomographic reconstruction estimates the dielectric distribution of the observed medium. Finally, adaptive detection algorithms isolate meaningful electromagnetic structures from clutter. This stage is equivalent to perception. Once the scene has been reconstructed, recognition begins. The temporal cortex transforms reconstructed electromagnetic structures into semantic identities. Range, angle, Doppler, polarization, scattering signatures, radar cross-section, spatial texture, electromagnetic fingerprints. All these features become a multidimensional representation. Recognition is therefore a classification problem. Recognition alone is not sufficient. The system must continuously estimate where objects are, how they move, and how uncertain these estimations remain. The parietal cortex therefore becomes the Bayesian spatial inference engine. Kalman filtering predicts future positions. Bayesian inference continuously updates belief. Range, angle, velocity, and angular velocity evolve into a dynamic electromagnetic belief map. Instead of isolated detections, the brain now possesses a stable probabilistic representation of the environment. Inside Wernicke's area, these local cognitive worlds are fused into one coherent representation. Here we introduce topos theory. Each cortical region possesses its own local logic. Visual logic. Recognition logic. Spatial logic. These local representations behave as local sheaves. Through gluing operations they become one globally coherent understanding of reality. Understanding is still not enough. Intelligence requires prediction. Inspired by Haken's cognitive radar, we extend the architecture with predictive electromagnetic working memory. Working memory internally simulates multiple future electromagnetic actions before any physical measurement is performed. Instead of reacting to measurements, the system predicts them. Prediction naturally generates attention. Attention is no longer a psychological concept. It becomes an optimization process. The system estimates which frequency, which antenna, which waveform, which viewing angle, and which region of space will maximize future information gain while minimizing uncertainty, power consumption, and computational complexity. Attention therefore controls electromagnetic resource allocation. The frontal cortex transforms prediction into decision. Every candidate's sensing strategy is evaluated. Different waveforms. Different frequencies. Different antenna subsets. Different RIS configurations. Different beam steering policies. Each action predicts a different future electromagnetic measurement. The optimal action is selected according to expected information gain, uncertainty reduction, and sensing cost. Decision becomes predictive electromagnetic optimization. Broca transforms decisions into executable action. In biological brains, this becomes language and motor planning. In EMBrain, this becomes waveform synthesis. Carrier frequency. Bandwidth. Pulse duration. Beam steering. RIS phase configuration. Antenna selection. Scanning trajectory. The cognitive decision is translated into an executable electromagnetic sensing program. The motor cortex executes the action. A completely new electromagnetic waveform is transmitted. The sensing geometry changes. The beam adapts. The environment is interrogated differently. The sensing system actively modifies its own future observations. This closes the sensor-motor electromagnetic loop. The system no longer passively observes reality. It actively shapes the information it will receive. This completes the next evolution of the electromagnetic brain. Version 4 transforms the original perception, action architecture into a complete multisensory predictive electromagnetic cognitive system. It integrates intelligent sensing, electromagnetic perception, recognition, Bayesian spatial belief, topos-based semantic understanding, predictive working memory, adaptive attention, decision-making, waveform planning, and sensor-motor electromagnetic action. Inside one continuous cognitive loop. Our vision is not simply to build a better radar, nor simply to imitate the biological brain. Our vision is to establish a unified engineering framework where electromagnetic physics, signal processing, geometry, memory, prediction, and cognition become different expressions of the same evolving computational language.